Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar. What do IoT device developers need to know about emerging IoT security regulations? Brought to you by Tech Online, Sectigo, and broadcast by AspenCore. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left at the end of today's program. However, if we're unable to get to your individual question today, someone will get back to you after the program is over. Also at this time, we recommend that you disable your computer's pop-up blockers. And at the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time by clicking on the red survey button at the bottom of your console. And if you're experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation. What do IoT device developers need to know about the emerging IoT security regulations? Discussing today's topic are Alan Grau, VP of IoT and Embedded Solutions at Sectigo, and with the 30 years of experience in the telecommunications and the embedded software marketplace prior to Sectigo, Alan was CTO and co-founder of Icon Labs. He architected Icon Labs' award-winning Floodgate firewall. A frequent industry speaker and blogger, Alan holds multiple patents related to telecommunication and security. And joining him today is Derik Poquiz, Enterprise Regional Sales Manager at Sectigo, and Derik has been a network sales advisor since 2003. It's with great pleasure I now turn this special session over to Derik to begin. Derik, take it away.
Hey, Chris, thanks. Appreciate that. So, hey, up until now, IoT security has been really a bit of a Wild West scenario. There really wasn't any legislation or requirements for security for IoT devices, and really most OEMs were so focused on building devices and providing solutions that they didn't focus adequately on security. And that's become the change, and we're going to talk about that today on our webinar. But if we look at where we're at, the problem is really severe, right? So statistics from Nokia's threat report outlines that almost 80% of the malware on their traffic, or malware traffic on their network, are from IoT botnets. But surprisingly, only 16% of the infected devices are the IoT botnets. So what that means is those IoT devices are the malware, and they're really busy, really active infecting and exploiting IoT devices. Partially because there weren't really any security solutions to detect that malware, but once they're on the network, they really don't have to worry about moving slowly. What they're doing is they're just going out, producing a lot of traffic, and really doing a lot of damage. Another thing outlined by the Nokia report is that IoT devices placed on that network would be targeted in a matter of minutes of first arriving. And that's because there's a large number of automated hacking attacks and systems out there scanning and looking for new devices, trying to hack into them. Part of it's because of those botnets are really busy trying to spread from device to device. But additionally, around some of the things that we found is that, the sources are saying that only about 5% of the IoT devices have what they categorize as meaningful security. And that's a little bit arbitrary, but I mean, what it really shows is that many of the devices out there, while they may have some security protections, they really don't have a comprehensive security solution in place. Even worse, they found that over half of the IoT devices that had a web interface on them had known vulnerabilities. And so what would happen is if a device with a web interface was placed on a network with a known vulnerability, within minutes, the botnets would find it, detect what vulnerabilities that they had, exploit it, and then go to work and taking over that device. the number of attacks just continue to rise. And, data from a report by F-Secure, they've got a number of honeypots that they place throughout the world. And, they use them to monitor what sort of attacks are occurring and what's taking place in the various networks and various systems. What they're showing is the number of attacks rose significantly from 2017 and 2018. But in 2019, just really in the first half of the year alone, the attacks almost tripled. Right, so ultimately, we're really seeing a sharp rise in the number of attacks. And while granted the data is a little bit old, it's really indicative of the current situation. So it's clear there's a problem, but again, does anybody care, right? And this was the Wild West scenario where people really just weren't addressing the security concerns. But the reality is people do care, and people are starting to take notice. And the way that's coming about is through legislation. What we're starting to see is more and more legislation pass. Beginning to address cybersecurity and IoT devices. The U.S. federal government passed a law in 2020. That law actually referred to the NIST guidance, as it relies on this to really help set the standards for security. But it does require some basic security capabilities to be built into the device. And this helps us to establish and start a framework and really a set of rules in securing IoT devices. In doing this, what we're looking to is really to move it away from the Wild West scenario, really, and allow us a situation for much better security controls universally on devices. Rather than the ad hoc solutions that each OEM might have around their own capability, and a few of which are really managing rigorous standards. In addition to what we've seen in the U.S. federal law, there also was a law passed at the state level in California, really being the first law passed to provide some meaningful requirements around building IoT devices. It really was the first step, right? So it didn't provide a great deal of security, but it did set that framework at the state level and really helped to set a precedent. Australia passed a law in 2020. That was a bit more comprehensive. And many laws in additional jurisdictions as well. One of these jurisdictions actually is the European Union, having passed ENISA, which is really prescriptive around security in IoT devices. With still more requirements in line with other markets and verticals, the FDA has even provided guidance for cybersecurity in medical devices. There are various organizations and groups working in cybersecurity initiatives, one for the automotive space, others like the GDPR. Even the GDPR, while not really designed for IoT devices, it impacts IoT devices, causing IoT manufacturers to take it really into consideration. But how does IoT impact the business? Alan?
Thanks, Derik. Yeah, so Derik, I appreciate setting the background in terms of what legislation has passed, and we really are starting to see broad legislation requiring security for IoT devices, and we'll get into that a little bit more as we go along. But I first just want to step back and talk about where the IoT is at and the impact of the IoT and the impact of the threats against IoT devices. Derik shared some stats on the number of IoT device attacks and vulnerabilities and some of those things. But if we take a step back and just look first at what's happening within the IoT, I mean, we've got all sorts of transformational new use cases, connected cars, smart factories, all these technologies that are coming together and really creating new applications and new opportunities, everything from driver tracking, patient monitoring systems, predictive maintenance solutions. And we're seeing broad adoption and broad changes, and really a lot of exciting things going on within the IoT. And these really have a very large business impact. I mean, if you look at predictive maintenance alone, I've seen numbers in the billions of dollars of economic impact that it can have. And if you think about it, that makes a lot of sense. If there's a production facility that has a system that's starting to fail, and you can detect that ahead of time, and during the next scheduled downtime go in and replace a part, the cost of doing that's really relatively low, versus if you don't even have visibility into that, the part fails. Oftentimes when something fails, it'll damage other parts. So you've got a bigger repair, a much more expensive repair. Then you have all the downtime that's unplanned. So you've got people that were in processes that were expecting to be working that are not, get backups in production. That's pretty significant. And even on things like optimization, I heard one use case, somebody that we were talking to, that is just a garbage collection system or company, right? So they're going around doing commercial pickup of dumpsters. And they've got a regular schedule. Everybody goes out once a week. They pick up all the dumpsters. And they're moving to a system where they can monitor how full the dumpsters are and only basically send out a truck to pick up the dumpsters when they're at 70% capacity. And they were predicting fuel saving cost, infrastructure cost in terms of number of trucks and so on, of over 50%, because they aren't making runs that are not needed. You also have happier customers, because if a customer's dumpster is overflowing and their pickup isn't scheduled for another week or for another few days, right, then the customer is unhappy. So you've got very big economic savings, economic input, and that's just optimizing existing operations. But in addition to that, there's tremendous opportunities for entirely new categories of businesses, in things like patient monitoring, home monitoring, even something simple like Airbnb. You're now able to manage a property, manage access to a property through a smart door lock without having to worry about physically accessing, providing keys, physically being there. Another one that I think is going to have a tremendous impact, over time is, what I'd call ride sharing 2.0. Uber and Lyft were really starting to change the dynamics of kind of the transportation industry. Obviously, all that's shifted a bit with COVID, but as things get back on track and we move forward, over time, especially in large metropolitan areas, we're going to start to see a shift from car ownership to just more of a true rideshare solution. I suspect that within the next decade, in major metropolitan areas, people won't need to own a car in most scenarios. And if you look at the average car owner, the average car is used a few hours a week. If we move to a true ride-sharing system, where when you need transportation, you've got an app, you request it, something we can do today, but it can be done where you've got fleets of autonomous vehicles that are, that have either a shared ownership or owned by a corporation. You can move from having cars that are utilized, 5% of the time or less, to cars that are utilized a much higher percentage of time. You eliminate, all the capital cost of producing more cars than are really needed. You eliminate the cost of, storing those cars in terms of garages, and it'll have a very, very broad economic impact, both at the individual level as well as developing new business opportunities. But as we look at this, we're also faced with a broad set of additional risk factors. So all these transformational new use cases depend upon new technology. And if we look at the kind of the traditional enterprise world, security researchers and hackers are finding vulnerabilities in systems, on a pretty regular basis, right? If you pay attention to the media, there's always a stream of new vulnerabilities that are discovered. Many of those are in systems, protocols, platforms, software solutions that have been around for a long time. They may have been in the field for 10 or 15 years. And we think of those as being fairly battle-hardened systems, and yet new vulnerabilities are still found. If we look at the IoT space, most of the devices are built upon new platforms, new protocols, new technologies that are not yet battle-hardened. And so, while developers are working hard to build secure applications, many of these underlying technologies are going to have security vulnerabilities, and it's just going to take time to find all those and flush them out. That coupled with what Derik was talking about originally, with many of these devices being built without a security-first mindset, And we really have a situation that is kind of rife with security vulnerabilities, and we've seen that with the proliferation of the IoT botnets. Add to that an increased criminal activity, with hackers utilizing botnets with IoT devices to do all sorts of nefarious things. Increased data theft. I think there's an opportunity that we're going to start to see more and more of what I'm calling ransomware 2.0. If you think about ransomware in the IT world, it's a pretty serious problem. There's actually a news report that just came across my desk this morning that Kia Motors has been hit with a very significant ransomware attack, mostly affecting their IT operations. It's also affected their mobile apps that are used to communicate with vehicles. And that's pretty serious. They're having trouble, serving customers, closing, the paperwork to close sales, all of those things. And so there's a very significant business impact. But if we think about ransomware on critical infrastructure or connected cars or connected medical devices, the situation is much more severe. If a hacker is able to breach an IoT device, of a certain class, generally that vulnerability is going to apply to the entire class of devices. So what that means is if a hacker is able to connect to and hack into a connected car and implant malware on a connected car, they can probably implant that same malware across the entire fleet of vehicles. So if you could have thousands and thousands of vehicles infected with malware, or thousands and thousands of medical devices affected with malware, that could affect not just a financial impact of a business, but could even affect human life. And so now the leverage that those hackers would have to extract a ransom is much, much stronger. I mean, what would the impact be if hackers are able to call up a leading medical device manufacturing company and say, hey, we've been malware and we can control thousands of devices and we can start to endanger patients' lives, or we can start to prevent cars from starting or disable their brakes as they're driving down the interstate. The impact of that is enormous. And so they've got much greater ability to not only extract a ransom, but the impact on businesses is huge. So, and the point of all that is that security really has to take a front and center stage in the IoT. I won't dwell on this. I mean, the attacks are real. We all know that. I mean, the statistics that Derik presented are, in some cases, pretty startling, right? An IoT device that's installed on a network that has a known HTTP vulnerability is going to be taken over within minutes. These are real world scenarios that Nokia is reporting on from things that they're seeing on their network. These hacking tools are very sophisticated. They act very quickly. They can fingerprint a device, discover, see that it has a known vulnerability, and exploit that very, very quickly. So it's a real threat. So Derik talked again about the IoT legislation that's being passed and continuing to be passed. Right, there's more and more of that on the way. There's not just government bodies, but industry groups that are proposing and creating new security standards across a broad set of industries. And so as we look at that, what do we mean by security? Well, the reality is in the IoT space, the overarching security concerns are really about the same as they are in the IT space. Right? We need to make sure that we have authenticated and controlled access to devices and to systems. The difference here is that it's not just an authorizing user, a human who's interacting with the system, but we're also authenticating devices, and often devices without a human operator. And we need to make sure that we've got protection from basic protection from cyber attacks. Ensuring data can't be stolen, communication can't be hijacked or spoofed. Making sure that malware can't proliferate on devices. Just all the basic fundamentals of security, making sure that the device is only doing what it should be doing. And then the other critical piece is integration with security management systems. And this has really been a lagging consideration in IoT security. Derik shared that something like 80% of the malware traffic on Nokia's network comes from IoT devices, but IoT devices only account for 16% of the infected devices. So what that means is nobody's paying attention to what's going on from a security point of view on these IoT devices. If an IoT device is infected with malware, it can be very noisy, and nobody will notice. That there's not monitoring on the device to see that suddenly it's sending out 10 times or 20 times the amount of traffic that it was before. Or if you've got an IoT device that has, say, a telnet interface where somebody can log in with a username and password, most of the time that IoT device doesn't have any ability to detect abnormal situations. And what I mean by that is a hacker could set up a script and start sending login attempts to the device, and the device will just know, I've got a login attempt, username and password doesn't match, drop it, go on to whatever's next. And suddenly it's getting thousands and thousands of login attempts an hour, and the device has no ability to notice that normally it gets maybe 10 login attempts a day or a week, but suddenly it's getting thousands of attempts. And so the hackers are able to, without much barrier, continue to proliferate these kind of attacks. But early detection is really critical. If those systems can simply report back, some information saying, hey, I've gotten 100 times the number of login attempts as normal to a security management system, then the security professionals can come in, take a look at the network, try to figure out what's going down and mitigate that attack or eliminate the attack before it proliferates. So there's really some important things there that need to be included. And these, again, just at a very high level. And many of the security regulations that Derik talked about are providing kind of high-level prescriptive requirements. They're providing details on being able to detect attacks, being able to report attacks, and some of those things. So again, it fits very well into this framework. And as I said before, the IoT threats are similar, right? We're talking about the same sorts of considerations at a high level as we do in the enterprise or IT world, but the solutions are different, and that's because IoT devices are different. We can't just take the malware solutions that are running in a corporate network, where you've got large network security appliances and apply them to the IoT, or even the solutions running on a laptop and run them on an IoT device. So we need solutions that are scalable to the small footprint devices that we find in the IoT space. So now I want to jump topics a little bit or segue into talking a little bit more about the details of the security solutions for IoT devices. And as we look at that, again, kind of building on the point on the last slide, IoT devices do create new security challenges, right? This is, in many ways, a space that requires unique considerations. That's just because of the nature of the devices. Some IoT devices are running Windows 10 IoT or a Linux-based operating system, but far more are running a specialized environment. They're often limited resource devices. The bill of material costs is a major consideration in the success of these IoT devices. So they're built with just the resources in terms of memory and processing power that they need to perform their basic functionality. They're often running either a real-time operating system or a specialized embedded operating system. And so the existing tools that we find in the enterprise and IT space really just won't work. So new solutions are needed. These devices are deployed without a security perimeter in many cases and deployed in the field. And that's an important consideration as well, because if you think, if I want to hack into Bank of America, the only option I have is, for the most part, is a remote attack, a remote network-based attack. In other words, I don't have the ability to walk up to one of their servers and start doing invasive physical attacks against the server, right? They're in a data center behind physical security as well as the network security that they have. That's not the case with many IoT devices, right? Many of the IoT devices are located in a place where someone can access them physically. They could potentially steal a device or even buy a device. Many are low cost. Take it back to their lab, start tearing it apart, and start doing physically invasive attacks to discover security keys, reverse engineer the firmware, all of these things that sophisticated attackers have gotten very good at doing. So it makes them more vulnerable in that regard. And another thing that's different is that IoT devices have, in many cases, a very long life cycle. Right? The laptop I'm using today, probably won't be in use 3 or 4 years from now, and certainly not 10 years from now. The car I'm driving, is very likely to be still on the road in 15 years. And so the security threats that it's going to be subject to are more advanced than what my laptop will see. Security threats will continue to evolve. You start to look at things like quantum-based computing, which creates a whole other set of problems for crypto systems, and building in capability to mitigate that is certainly possible, but those are all emerging technologies. So it just creates a whole new set of challenges that developers need to look at. So how did we get into this situation? And part of it is, as Derik had talked about a little bit, when people were building initial early IoT devices, there was a rush to market. There was an assumption that the devices would be on private networks and not accessible to hackers, or would be low-value targets and people wouldn't bother hacking into them. The other problem is that we've kind of relied on early technology for device identity, right? And so if we look at how authentication evolved in the IT world, right, we started out with username and password, a simple static credential. We've realized that that's not a very good solution, so we've evolved to multi-factor authentication, managed identities in an enterprise environment, and better solutions. And now we're moving away from those into passwordless solutions. Even multi-factor authentication solutions, while better than pure passwords, have been shown to be weak and to be quite vulnerable in many scenarios. But in the IoT space, these are headless devices. There's no human there to enter a second factor, a PIN that's been, or a code that's been sent as a text, or other multi-factor authentication technologies. So we've had this huge proliferation of static credentials, username and passwords, oftentimes hard-coded, many times default passwords and that weren't changed. And so it's led to very weak security. And that's one of the critical things that needs to change. And so, that's kind of the identity side of the concern with IoT devices and IoT security. The other half of the problem, or the other part that needs to be addressed, is integrity, right? How do we ensure the integrity of the firmware on the device? How do we ensure the integrity of all the communication that the device is doing, the data in transit problem? And many IoT devices have critical information stored on them, sensitive data that needs to be protected. So how do we ensure that that's protected and not easily exploited or stolen by hackers? So these are kind of the two halves of the problem, in our view: device identity and device integrity. And as we look at that, Sectigo started out as a certificate authority company, so our background is issuing certificates, issuing digital identities, and certificate-based authentication is really an ideal solution for digital identities for IoT devices. Right? You can issue a certificate to the device. It gets away from the username and password or weak static credentials. You don't have to worry about implementing multi-factor authentication in an environment that it doesn't fit. So that's part of the solution. And then the other part is providing kind of the embedded security solutions for the device to ensure integrity. So kind of the full picture for security is device identity plus device integrity. And device identity, again, there's the certificate issuance part of the solution, and then there's the ability to manage certificates on the device or within an IoT management solution that's the PKI agent can be utilized for, that allows the device or a system that's communicating with the device to verify that the certificates are up to date, issue new ones, renew certificates, and handle that. The other part is ensuring things like secure key storage. And one way of doing that is using a TPM chip or other hardware secure element for IoT devices. And again, that's a really, really critical piece. If we look at the PKI solutions on the cloud side, there's strong security around protecting those keys, but you need something that's also suitable on the device side. Then some of the other elements are things like secure boot, secure updates, and embedded firewalls to allow detection of attacks. And all of these are components that help meet the security guidelines that are being enacted, both, again, through industry organizations and through the legislation that we're seeing. So I want to talk a little bit about the specific solutions that are available for meeting these requirements. And the first is Sectigo's IoT Manager. So this is a cloud-based certificate issuance solution that's designed specifically for the IoT. So it provides a high availability cloud-based system for issuing certificates. And again, it supports certificate issuance through using either ECC or RSA certificates. Again, managed through a single administrative portal. So you've got an easy way to issue and manage certificates. ECC for people who spend a lot of time in the PKI and encryption world, ECC is an ideal fit for many IoT use cases because it provides strong security, strong encryption with much shorter key lengths and easier processing capability than RSA provides. So for IoT devices with limited resources, it's really an ideal fit. Also provides programmatic issuance, so you can use a REST API or protocol so you can automate the process of managing certificates on the devices. And this is based on a very highly available, highly secure hosting service. So it's a Web Trust audited issuance platform, from a company that's been doing this for 20 plus years, issuing public certificates with kind of the highest level of possible security requirements. And then some of the things that are unique about this for the IoT space is it's very customizable for IoT use cases in terms of certificate profiles, in terms of allowing each OEM to have their own certificate profile, their own private trust ecosystem. And what we see in the IoT space in most cases is that certificates are issued using what's called private trust. And that means that an OEM can have its own root so that all of its devices can interact with their systems, but they're only interacting with each other. They aren't globally trusted. And for most IoT use cases, that works well. We do see another level of that where there are a number of multi-vendor ecosystems. So an example of that is something called the SunSpec Alliance that is used to issue certificates for companies that will interoperate, providing electrical equipment working on the electric grid. And there's some specific regulation right now in California, but probably will be nationwide in the near future, requiring people that are putting certain types of solar equipment on the grid to follow these interoperability and security standards, one of which is requiring use of PKI and certificates for authentication. And so in that case, you've got a root that's, while private, it's used by multiple companies, but only for that specific use case. And that's as opposed to, or different than the kind of the public trust use case, where any web browser can connect to pretty much any web server because the roots are trusted globally by all parties. And in a few cases, there are IoT devices that need that same type of security. And so PKI can still be used in that scenario for IoT devices. And so as I mentioned, the system has a very flexible interface for doing cloud-based issuance, either with a user that can interact with it and request certificates, check status, or programmatically through an API or some protocols. And again, just provides some very simple ability to create certificates either one by one, where the device generates the key, or create batches of them, where the CA creates the keys and pushes those down to the devices. And those are all things that can be done in a very flexible manner, depending upon the specific requirement of the customer. So the other half of the PKI identity solution is how you need to issue the certificates, but how do you request them? And so we said that could be done programmatically, and we provide a PKI client to enable that capability. So it allows you to automatically or to easily integrate into workflows to create certificates for initial issuance or renewal of certificates. And by being an API an SDK that implements the APIs, and again, it's very flexible to allow you to integrate with provisioning systems working in a factory as devices are initially manufactured, or it can be used with an IoT device management system that's configuring and enrolling devices as they are first installed on a network. So there's a lot of flexibility in how this is used and can be used with a broad set of customer use cases and different workflows. So then in the other half that I had mentioned was how do we ensure the integrity of the IoT devices? And one of the critical capabilities is secure boot. And at a high level, secure boot really is just code and systems that ensure that when a device boots, that the firmware running on the device hasn't been tampered with. It's the authentic firmware from the OEM or from a trusted party. And secure boot's a capability that has to be built into the device by the OEM. Right? It really can't be added after the fact. And part of that is because it depends on this concept of what's called a root of trust. And in the case of secure boot, or in the context of secure boot, root of trust just means that you've got some piece of code running on the device that's immutable. It can't be tampered with. And that way you have a known trusted starting point. And then from that root of trust, you can validate everything else on the device and make sure that it's not been tampered with. Now, implementing this requires some provisioning capability, so you have to have a way to program the information onto the device that has, the signatures and the validation capability on the device. And as with all other IoT security solutions, it's got to be scalable. The memory requirements and availability for many IoT devices is pretty limited, so it has to be something that will work with these small footprint devices. Another really critical capability is an embedded firewall. If you look at the laptop that I'm using right now for this presentation, has a firewall embedded within it to monitor traffic coming in, control and block certain points. Network systems, firewalls are ubiquitous. And there's really no reason that embedded devices don't include the same functionality. A firewall on an embedded device can lock down what ports and protocols are utilized, but it can also do intrusion detection. So if you get back to the scenario I talked about before, where a hacker starts trying to log into a telnet port on a device that, and starts running large numbers of attacks against that, a firewall can report those anomalies. It can report the anomalous behavior on the device. And, that way you've got network visibility and can start to do something to shut down the attack. In some of the use cases that we've seen for this, there was an example a number of years back. A fairly famous or well-known hacker had tweeted about being able to hack from the airplane Wi-Fi on a flight during the flight into the control system on the flight and issue climb commands to the aircraft, actually changing the altitude that the aircraft was flying at while it was in flight. And he tweeted about this. The next time he was about to get on a flight, the FBI decided to spend a little quality time with him. And I actually did a fair amount of research to try to find out details around this. And there was never any published report from the FBI or anyone else acknowledging that that activity had taken place, that he was actually able to successfully doing that, or denying it. But subsequently, many aircraft have begun adding firewalls into their system to block traffic between those two networks to keep them segregated and to provide reporting. We've also seen significant adoption of this technology in the automotive space. Automotive systems are more and more connected. There's more and more communication between components in the car, between the car and external components, and having firewalls in place to monitor, detect anomalous activity, block unauthorized activity is really an important capability. But it applies really to all IoT devices. Any system that's communicating should include this type of capability. Another one of the really critical components is secure key storage. And I mentioned this a little bit with the TPM integration, but the way secure key storage is implemented will depend on the architecture of the device. If you've got something like an ARM trust zone solution, you can utilize where it's a single chip solution, but you've got segregated portions. We've got a secure world and a normal world, as they're often called. You can implement security critical capabilities in that secure world and ensure that they're protected from any attack that is able to access the normal world. And so that's one common scenario. Another is to use a TPM chip or hardware secure element. And there are low cost, one of the considerations, as I mentioned before, is bill of materials cost. And TPM chips are now ubiquitous in in Windows laptops, Windows PCs, and devices like that, and in high-end IoT devices as well. But I mean, the cost of that might be $1 or $2 per device, which, again, depending on the bill of materials, may be fine. But if you've got a very low-cost device, it becomes cost prohibitive. And many of the leading providers of chips in the IoT space do have low-cost hardware secure elements that provide secure key storage that can be utilized. And so that's a great way to go as well. But oftentimes there are legacy devices or devices that were designed without those capabilities that still need to use cryptography and need to store the keys securely. And so there are software-based solutions that can be used in those scenarios. I think the software solution provides a great stepping stone towards a hardware-based solution, which is really where companies need to end up ultimately, but it's a good starting point. And then finally, how do you know what you built was secure? And you can start out with vulnerabilities with a kind of a security architecture review to make sure that architecturally you've included the components that we're talking about in terms of intrusion detection, firewalls, secure boot, and so on, and device identity. But penetration testing is really a great service on the back end, making sure that the cloud services, the protocols, and the IoT devices themselves all are built in a way that has strong security and that don't have vulnerabilities. Great security solutions, if they've got a vulnerability in the implementation, really can fall flat. And sometimes those can be pretty obscure and hard to find, and penetration testing is a great way to do that. I mean, Cisco, a couple years ago, I think now, maybe a year ago, I'd have to go back and look at the dates, had a vulnerability in their secure boot solution for some of their routers. And Cisco is a company that has tremendous resources, great expertise, and has made security a priority. And so they were doing the right thing, building in secure boot, but hackers found, I think actually some security researchers found a way to circumvent that. So it's important to include the solutions, but then you need to make sure that they're done right. And security is one of those unique capabilities that it's important to get it right, but it's easy to get it wrong. I mean, little mistakes can result in vulnerabilities or software that behaves in unexpected ways that results in vulnerabilities that can be exploited. So vulnerability penetration testing is a great solution. And kind of an ongoing vulnerability assessment is another important component of that, right? Each time you do an update, to be able to automate the process of rerunning some vulnerability assessments, some scanning and checking for those sorts of problems is another really, really critical piece. And then there are also solutions available for doing firmware scanning, which would be, again, a part of this, where a company can take their firmware, run it through a firmware analysis tool, and there are companies that are building firmware analysis tools that are specifically for IoT that will reverse engineer the code and can find things like known CVEs, known vulnerabilities, which again relates back to the point Derik made that on the Nokia network, I think is where it was, that something like half of the devices with a web interface had a known vulnerability in them. And so, there's really no reason for that to be released. There's known vulnerabilities, there's known fixes. Those things have to be addressed. And those firmware analysis tools can find those sorts of problems, along with other things like hard-coded keys and passwords, and a whole other sets of vulnerabilities. So there's a lot of things that can be done to ensure security. So in terms of, why Sectigo, we're a company that's been very heavily focused on security. We've got very robust, mature solutions. And many of those are designed specifically for IoT devices. Having a commercial solution allows the company to have one solution they can employ across a wide range of devices. So you don't have to build a new solution for each individual device. It can really standardize on something that's specific for your device, or specific for your, not specific for your device, but capable of supporting all of your devices. And I'd mentioned earlier on PKI that there's a couple of different use cases for it. There's the private trust, where a specific OEM will have their own root CA that they'll use, and can authorize and identify any devices working within their ecosystem. But there's also many, and I mentioned the SunSpec Alliance, but there are many other industry consortiums where different companies are building equipment that have to interoperate. And these consortiums exist to help manage that process. So there are a number of solutions that PKI works very, very well for. So just one last thing I wanted to mention. If you like this, we do have a podcast called Root Causes that you can check out that really is a little more general on PKI and IT security. We cover IoT topics on that. A couple of my colleagues at Sectigo produce that. I've been a guest on that a few times, so that's something that you could check out. And with that, I will turn it back to Chris to cover any questions.
All right. Well, thank you, Alan, and thank you, Derik, for a great presentation. As a reminder, please fill out the feedback form that will open up at the end of the show. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're now going to move on to the question and answer portion of our event. As a reminder, if you'd like to participate in our Q&A session, simply type your question into the text box located to the right of the presentation window, or you can click on the Q&A icon at the bottom of your screen, type your question in, and then click the submit button. Please note that we'll try to get to as many questions here as we can in the time that we have left. If we're unable to get to your individual question today, someone will get back to you after the program is over. So let's get started with some questions for you. It looks like we have several coming in. Our first one says, do you provide or recommend particular HSMs for IoT devices?
Yeah, I can. This is Alan. I can take that one. We have partnerships with a few companies that build HSM devices or secure elements for IoT devices, but the specific requirements really depend upon the nature of the device. And we're a software company and do try to work with with the requirements of the customer. And I guess one point I'd make here too is when I talk about HSMs, I tend to lump them into two categories. There's the network HSMs or the enterprise HSMs that we use in our data centers to support our PKI operations, and those are very expensive solutions that are again exist in the cloud or in the data center. And then there is the device side HSMs, TPM chips and others that are much lower cost, $1 or less in many cases, as opposed to thousands of dollars. So if we look at the device side, again we can work with a pretty broad set of device specific secure elements. But again, a lot of the requirements depend upon the device, and not only the price point, but the specific algorithms and so on. So we can certainly work with customers on that, but it's not a one-size-fits-all solution.
All right, thank you, Alan. Our next question asks, do ENISA, GDPR, etc. apply only to devices that are manufactured in those regions, or also to devices that are manufactured elsewhere but sold within those regions?
No, great question. No, I think it really applies more to where the devices are deployed. That was one of the reasons that the California legislation was actually quite powerful. It was limited in scope, but the reality is anybody selling a device in North America, which is a large percentage of manufacturers, are going to sell the device in North America or in California. So you don't want to build a device that has two different SKUs or has specific implementations for a different region. So even though it only applied to California, by extension, it really covered a large number of OEMs.
Did you hear me, Alan?
So no, I didn't hear anything else. Was there another question?
My point. My apology. At some point, can you speak to IoT devices which are behind a firewall that block incoming traffic but connect to manufacturer-provided clouds? Are those being hacked?
Sure. No, I think this is actually this is a great question because it gets to one of the myths or early reasons why many IoT devices didn't include sufficient security. I mean, if we ignore IoT for a moment and look at the number of data breaches that happen in the IT world, you know, it's very clear that hackers have proven to be very good at getting around network firewalls or getting past network firewalls. And that's so yeah, absolutely. I mean, it's critical that all IoT devices have high levels of security. And you know, the other consideration with that too is if you're an OEM building a device, you don't necessarily know where and how it's going to be deployed. So I think that's you know, in many cases, maybe some of your devices are deployed behind a network and therefore have some protection. But some won't be as well. So either way you look at it, no, I think it's really critical that all devices include strong security.
All right, thank you, Alan. Another question came in that asks, it says, my question is at what layer does an IoT device work? And also, can you define an IoT device? Sure.
So, I mean, IoT is a fairly broad term, right? I mean, the idea is an Internet of Things device, and that can be anything from a smartwatch to a connected car. But you know, really, any device that is communicating to a network or you know, to a cloud system is an IoT device. And at the same time, you know, there are other devices that you may be considered traditional embedded devices that may not meet the strict definition of an IoT device, but you know, even in that case, if the device is communicating and has communication capabilities on it, you know, then adding security is still an important requirement. And then the other question is at what layer is the device operating? You know, if you're thinking about that in terms of network, the networking layers, you know, the IoT device will have protocols really operating kind of across the layers, you know, from you know, application layer down to the physical layer. So if that's the context in which you're meaning layers, then it really operates across those layers.
All right, thank you, Alan. Another question has come in asking, what are the possible solutions to add security solutions to a device which is already in the field?
Sure, no, great question. And you know, in that case, the answer is somewhat going to be, you know, it depends. If the device can be upgraded, then when you do the next firmware or software update to the device, you know, certainly possible and worthwhile to add security solutions, you know, software security solutions to the device. And this is one of those cases where, you know, I always think it's best not to let perfect become to defeat the idea of doing something that's good. So, you know, if the device doesn't have, you know, hardware secure key storage on it, that doesn't mean that you can't still add other capabilities to build greater security into the device. And it may not be as robust as if you're building the device from the ground up, but it's still worth doing. And then, you know, the other approach, and there are companies that are very focused on building, you know, security devices, you know, hardware security solutions that can build network controls around IoT devices. And in some scenarios, that's an important part of the consideration or important part of the solution. It really just depends upon the context. But if you look at industrial control networks, there are companies that are building systems to monitor and detect threats in that environment where even if you can't update the firmware on the device or the device itself, you can add some additional network layers of security that is valuable.
All right, thank you, Alan. Another question came in asking, you mentioned several different IoT security laws that have been passed. Are there different requirements for each law, or are they very similar?
For the most part, they're similar, and I would say, you know, some are more comprehensive than others. So, you know, the California law, for example, really just provided some requirements around device authentication and not allowing hard-coded and fixed passwords. Many of the other laws have built upon that and provide more comprehensive requirements. But in general, they are similar. Cybersecurity at many levels is similar regardless of the type of device that you're building. So the high-level requirements are generally quite similar on those. It's just a matter of how comprehensive they are.
All right, thank you, Alan. Another question has come in asking, you discussed PKI for device identity with IoT devices. So how do you manage certificate revocation for IoT devices?
So, great question. I mean, and that, again, the answer kind of depends upon the requirements of the specific use case and the specific device. Some manufacturers, are using long-lived certificates and just hoping that they don't have to implement revocation, which it was kind of where many of the first adopters were at. We're starting to see people move more towards implementing either OCSP, which is called Online Certificate Status Protocol, or CRLs, which are certificate revocation lists. And in the broader PKI world and public internet, OCSP has become the preferred solution, just because CRLs in the public world have become too long. The number, as certificates are revoked, the number of certificates on a CRL gets to be unwieldy. But in the IoT scenario, CRLs still can be used in many cases because you don't have to worry about, you only have to worry about certificates issued within your own ecosystem. And if you're an enterprise that has 10,000 devices that you're deploying, or 1,000 devices that you're deploying, if a few of those have to have a revocation event, only a few certificates are revoked, it's a fairly short CRL and it's still managed or manageable. So it really depends upon the use case. And then we're starting to see, not quite so much in IoT, although it's starting to a little bit, but in some other environments, DevOps, for example, where people are going clear the other way from the long-lived certificates and doing very short-lived certificates. So they'll have an automation process in place so that certificates are renewed every 24 hours, every week, some cases every few hours. And in that case, certificates turn over so quickly that that you don't even have to worry about revocation. So it really depends upon the environment, and that's one of the challenges of the IoT space is that many of these solutions do need a lot of flexibility to be managed.
All right, thank you, Alan. We've got time for a couple more questions here. So our next to last question for you: how do you protect your devices from being identified on something called Shodan?
Oh, interesting question. So just to back up a little bit, so Shodan is a search engine. Some people have called it the search engine for hackers, but it's a tool that originally was developed by a research group where they went out and scanned for connected devices, for IoT devices, and so you can go in and you can search on a variety of criteria and discover IoT devices that are connected to the network, and as well as information about those devices. And so the question being is, can you protect your devices from being detected? And I haven't looked at Shodan for quite some time. So I think that it probably is difficult to prevent your device from being detected by Shodan if it's on a public IP where Shodan can find it. But what you can do to mitigate that threat is just to ensure that the device doesn't have open ports and protocols on it that allow communication with the device. Because if Shodan can communicate with the device, it can gain more and more information about it. You can kind of fingerprint it and provide a more detailed report on what the device is. So if you don't have open ports and protocols and you have strong authentication, so you only communicate to somebody else that, say, is within your PKI ecosystem, Shodan may be able to ping the device and say that it's there and what the IP address is, but then it wouldn't be able to communicate with it to provide that sort of detailed information.
All right, thank you, Alan. Looks like we have time for just one final question here. Our final question is asking, can you talk about the common types of attacks in IoT devices?
Well, that's probably a more than 1 minute answer on that. That's a big question, but it depends a little bit upon the specific type of device. I mean, there are specific device or specific attacks rather that have been developed to attack certain, say ICS type devices, industrial control system type devices. But it's at some level, the ones that are highly common are some of the botnets like Mirai that we've seen, that have been very prolific and have been able to, gain control over thousands of IoT devices. But on the other hand, and this goes back to what Nokia was saying, that if an IoT device shows up on a network, hackers will detect that device within minutes of it being first coming onto the network. And those are automated attacks that are just running kind of a barrage of attacks. So the reality is, at some level, if an IoT device is on a public IP, it's probably going to be subject to a pretty wide range of attacks.
All right. Well, thank you, Alan. That does look like all the time that we have for questions for today. I'd like to thank Derik and Alan for their time and expertise on today's topic and a great Q&A session as well. Once again, for more information related to today's webinar, please visit any of the resource links available in the green folder icon at the bottom of your screen. And within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Once again, we'd like to thank you for attending today's webinar. What do IoT device developers need to know about the emerging IoT security regulations? Brought to you by Tech Online, Sectigo, and this webinar is copyright 2021 by Aspen Core. The presentation materials are owned by or copyright by Tech Online and Sectigo, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests and Sectigo, I'm Chris Keach. Once again, we'd like to thank you for joining us, and we hope you have a great day.